Okay, so let's move into the notes. Okay, so yesterday at the end of the period, we were doing this problem about this grocery store. We found the mean monthly salary was $1,700, and the standard deviation was $603.56.
Thank you very much.
Yeah, me too.
Okay. Okay, so.
Can you hit record?
Yes, I did. So, hopefully, if you have your calculator, you didn't clear it overnight, and you still have the data entered.
I got you.
If you cleared it up, maybe you want to re-enter it right quick into L1.
One second.
So it looks like I ain't enter it because I cleared mine out last period.
Ooh, well, I'm up there. Nice enough. Holy.
On the bus?
When I get on the bus.
I'll say, hopefully you don't need to take the nap in here.
Got to slip on this little dust.
Okay, so let's enter our data in if we need to. I'm going to do mine right quick.
What number are we on?
We're on the bottom of page 8, about to go to page 9.
We already did this one.
Yes, we did. We're going to use the same data, though. Okay. My data's entered back in there. Okay, so let's say we're working at this grocery store, or we're the manager of this grocery store, and we had a really good month. So we're going to give everyone this month a $100 raise.
Is it like $100 or just like $100 like every week or salary rate?
$100 every month raise.
That's a nice raise.
Because that's what we're dealing with here, monthly salaries.
Oh, okay.
So we're dealing with monthly salaries. There we go. So now we need to calculate a new mean and standard deviation. What I recommend doing is going into L2 on your data bill in your calculator and just adding 100 to everything in L1. So first data point 3,500. It'd be 3,600. So let's do that right quick. Add 100 to each of them. And put that under L2.
you should put that in the two.
Put that in L2. Did you put it in L1?
Maybe.
That's fine.
Oh, it's all right.
That's okay. Just when we go do the third part to this example, make sure you refer back to your original numbers. So make sure to put it in L2. That way you don't delete your original numbers.
Do we actually have like L1 when we put the original numbers in L2?
Yeah, that's fine. Just keep track of where your original numbers are. Okay, so once you get them entered, make sure you know which list they're in. Are they in L1 or L2? Hopefully they're in L2.
Yes.
We'll want to go and run the one variable stats like we did yesterday. So stat, calculate variable stats. Now if you put them in L2, you'll need to hit second stat so you can go and change the list.
Okay, so it's one variable stat what?
One variable stat, and then when it comes up, you'll probably see an L1 there.
No.
Let's see.
Mine says one variable stat.
Oh, yours goes back to the home screen, doesn't it?
Yeah.
Okay. So even if it goes back to the home screen, yep, second list.
Check that, and then.
And then
I did
put
L2, didn't I? Right.
wherever your one where you added 100 to it.
Okay. Got it. And then enter.
And then enter.
Whatever.
So what did you get for the meat? Yep. So is this the original data here? Okay, so let's go over to this. And then add 100 to each Okay, so let's go over to the next column. Let's see. Okay. Stat calculations. One variable stats. Number list, yep, list.
Okay.
It's gonna ask you what it's in column B, so we want the B right there.
So next one is the.
Yes.
Yeah.
It.
Like I said,
Yep, it's right there.
like I had a time.
Well, that's the sample. So we're gonna need to go down.
It's either the two. Right?
Okay, what y'all get for the mean over here? Or do we get stuck? So stack. Calculate.
Yes.
And then one variable steps.
Thanks.
That's what we did yesterday. And then still be one variable steps. But this time we're going to do second list.
Did you get the sum?
L2.
So what do we put in for the name number?
Okay. Okay, so are we confused on what numbers to put in this time? So we want to add 100 to all of these.
What I do.
Did you get them all in there?
This one?
It's 14. Okay, so now hit staff again. And calculate. And we'll go variable steps.
This one?
And then runs from second list. And the second, the blue second. Yep. And then go hit staff. That's what we want. The second step. Second.
I did.
Second. There you go. And now hit L2.
Okay.
There you go.
Here, right down.
Okay, I think we're on the same page now. So what y'all get for the mean? What y'all get for the mean on this one? The X bar, the X with the bar over it. 1,800, good. What about the standard deviation? So sigma. That's right. So what do we notice about our means? What happened to them? It increased by 100. Oh, that's interesting. Standard deviation stayed the same. Well, let's look at the box plot. So y'all have to draw this. Just kind of pay attention. So on the first one, it's lower. Then we added 100, and the whole plot moved 100 to the right. So if you add the same amount to every number, you're just shifting it over some. You're not changing much of anything. You're just shifting it. Let's say the boss didn't want to give everyone a $100 raise. He wanted to do a 20% raise. So on this one, what can we multiply our original amount by to get the new total amount?
1.2.
1.2. And if you're like, what, huh? What? I'm going to write it on here, but then I'll have to erase it because this is a different example. If we let X be our salary plus a 20% raise, well, how many X's do you have here? Well, physically there's 2. But if we combine like terms, we get 1.2x. So that's why we can just multiply by 1.2 to get our new salary. So in L3, multiply your original salaries by 1.2. Now, you don't have to sit there and calculate back and forth with 2 calculators. You can actually enter it in. So our first one's 3,500. In the first one on L3, you can type in 3,500 times 1.2, and boom, hit enter, it calculates it for you. So that's what we're going to do in L3. We're going to do 1.2 times whatever your original values are. Once you get that entered in L3, run your stats calculations. Okay, so what did y'all get for the new mean?
$24.
2004. Okay, what about the new standard deviation?
724.27.
Yeah. That's right. So notice that both your mean and your standard deviation increased by 1.2. So that was our original. It increased, each one increased by 1.2. So if we look at the box plots, notice what happens. This was our original. Then we added 100 to get the second one. But then what happened from the original to the third one? It increased, but it also was stretched. So multiplying by a constant stretches out our distribution. That's why our standard deviation changed. Okay, so this leads us into our next topic. Yes.
Was the standard deviation was 700.4?
Yes. That's right. So let's look at the mean and standard deviation of linear functions. That's our next topic. If x is a random variable with the mean mu of x and standard deviation sigma sub x, and a and b are numerical constants, then we can find the random variable y to be a plus bx. Then for the new mean of y, we simply just plug in the mean of x in place of x. So those are our formulas to write down on page 9. So the mean of y is equal to a plus b times the mean of x.
Is it, okay, is it A plus B like that, A plus B times the mean of X, or is it A plus B times the mean of X?
It's a plus b times the mean.
Okay. Let me see that.
And then our new variance would be b squared times the variance of x, which means our new standard deviation is the absolute value of b times the standard deviation of x. So instead of having to re-enter everything into the calculator every single time, we can do these linear transformations using these formulas to get through it a lot quicker. If they're not on your formula sheet, then Yes, you would have to memorize.
Mr. Schultz, just kind of like to recap. Whenever you, the A plus 1 can do of X, I'm sorry, I just got kind of confused. So like, if I put parentheses around B plus B times mean of X, that would be correct. I just make it.
Yeah. Yeah, you'll multiply these two first before you add A to them. Don't do A plus B together. You multiply first, then add the A. So they're on the formula sheet. Let's see. Nope, you gotta memorize it. Yeah. You always gotta memorize these. Now, dual credit, I don't know if this type of stuff will be on your test. I don't think it will. So, this is just stuff we've got to cover because of AP. So, don't stress too much over this.
Like the third one on that?
Yeah. I mean, you'll have to know how to find the mean and standard deviation and stuff. But as far as like all these transformations and everything, I don't think I'll be on the test.
Yes, sir.
Okay. Let's look at the propane example. So consider this experiment where a customer of a propane gas company is going to be randomly selected. Let X be the number of gallons required to fill his propane tank. Suppose that the mean and standard deviation is 318 gallons and 42 gallons respectively. So let's write that info down before we even read any further. X is the number of gallons, so the mean of X is 418. No, 13. Where am I getting the 4 from? Exactly, 318. Standard deviation of X is 42. And these are both gallons. The company is considering a pricing model of a service charge of $50 plus $1.80 per gallon. Let Y be the arena variable of the amount billed. So how can I come up with an equation for how much they're going to bill the customer? What would my equation be? Yes, but let's write that switched around. That way we have the A plus BX format. So you're right. Let's just switch it. So we're going to say Y equals 50 plus the $1.80 times X. Now they ask us to find the mean and standard deviation for the amount billed. So this is where we use our transformations. So the mean of Y is equal to, well, that's going to be B plus A times the mean of x. Well, what's our b in this case? 50. Our a is $1.80. And we said the mean of x is 318. Our mean comes out to be what?
Mr. Schultz, why did you switch from A to B to B to A?
Did I switch?
Like on the example that you gave us, up top it was A B times mu x, but this one shows B plus A times mu x. Oh, my bad. I just got confused.
That's totally my fault.
Oh, you flipped them?
Yeah, I accidentally flipped them. So that was totally my fault.
Oh, good. I was just confused.
Yeah. Yeah, thank you for bringing that up.
Oh, good.
If y'all see stuff like that, don't hesitate to say something.
I just thought I missed some.
Yeah. Okay, so when we calculate this, what do we get? Yep, and since this is dealing with money, because it's how much they pay, it would be $622.40. Now, standard deviation. Remember, that's the absolute value of b times the standard deviation of x. So the absolute value of 1.8, which really doesn't change anything because it's already positive, times 42. So we have this one. Yep, and since it's in terms of dollars, we'd say $75.60. That's all they ask for. Let's turn the page and go on to the next example. Let me thumb through the PowerPoint just to make sure we didn't miss anything. I think we did. Got it. No, we didn't. Okay. Okay, so they give us all this great, lovely information. X is the number of sales staff needed. They have a fixed cost of $255. Cost per salesperson is $110. Find the mean cost of doing business on a given day. And then they also ask us the variance and standard deviation. Okay, so yesterday, how did we find mean if we're given a probability distribution? We will eventually add, but what do we have to do first before we can add? Multiply x and the probability. Perfect. So this table is big enough that I can just extend it. So I'm going to extend it. We need to multiply x times the probability of x. So 1 times 0.3 is 0.3. 2 times 0.4, 0.8. 3 times 0.2, and 4 times 0.1. So now to get the mean, we add them all up. And what do you get? 2.1. So the mean of x is 2.1. But they don't ask us for the mean of x, they ask us for the mean of y. Well, remember for mean, you can just plug the mean of x right into the equation for the mean of y. So we would do 255 plus 110 times our mean of x, which is 2.1. Mr. Schultz? Okay.
It's on there. I'm gonna go to the.
Okay. Okay, so what did we get for the mean of y? 486. Yep, and we're in dollars again, so we're going to just say $486. That's the first part of this example. Okay. Second part, they ask us to do variance and standard deviation. So I'm going to condense what we did yesterday into just one step. So this is where we're going to have to take each x value, subtract the mean from it, square it, and then multiply by the probability of x. Now you may be thinking, that's a lot to do in one step. Here's what it would look like for the first one. So my x is a 1 minus our mean. What did we say the mean of x was? Up above. 2.1 squared times our probability. What's our probability of x being 1? 0.3. So we're doing all of that in one step on here. So if you type all this in at one time, what would that give you? 0.363. Okay, then we do the same thing for 2. So you would do 2 minus 2.1 squared, but this time we multiply by 0.4 because that's our probability. So when you do that, what would you get? 0.004. Now I'm not going to write the next steps blue out here, but the process would be the same. You put a 3 here, minus 2.1 times 0.2. So what would you get for that one? .162. And then last but not least, we have where x is 4. .361, that's right. Now we gotta add them all up. .89. So what does this .89 give us?
Variance.
Variance of x. So this is our variance of x is .89. What's my standard deviation of x? The square root of .89, which is 0.9434, that's right. But they don't ask us about x. They ask us about the variance and standard deviation of y. So we're going to do, to get the variance of y, b squared. So which one of these is our b? The 110. The 110 squared times 89. What would that get you? $10,769. Yes. Now, if we wanted to put units in, our units would be dollars squared. But does that make much sense? So we're going to need to square root this to get just the standard deviation of y. 103.77. So we're in dollars here. That's our standard deviation. Okay, so Julissa has been signed out. Riley and Brandon, if y'all want to head out a minute early. Okay.
So you said we can get the homework turned in by Saturday?
Do we have homework? Or are you gonna do the top right now? No?
Now, the only one y'all have to worry about is 4.1. Good luck tonight at y'all's first district game.
Good afternoon. I'm sorry to interrupt, but just a quick announcement. If you will release the varsity football players at this time. Thank you. Bye-bye.
Yes.
Okay.
Have a good one. Yeah. Okay, questions on this example? No? You have a question?
Oh, no.
No? Okay, let me go to PowerPoint to make sure I didn't miss anything. Nope, doesn't look like it. Nope, I didn't. Okay. So now let's go to the next example. So suppose we're going to play a game called Statland. Players will spin 2 spinners and move the sum of the 2 numbers. So spinner A just goes 1 through 4, but spinner B goes 1 through 6. So they'll spin spinner A, spin spinner B, add them together, and that's what they move. So it looks like they just asked us to list all the possible sums. So let's list them out. By now you're probably thinking, where's the catch here? Because that seems kind of easy for this problem. Just listing all the possible sums. Well, yeah, but let's just start there. So if I spin a 1 on spinner A, what all could I get on spinner B? 1 through 6. So I'm going to need to add all those together. 1 plus 1, 1 plus 2, 1 plus 3. And then I can go and I'm not going to add them right now. I'm just going to try to list all my options, but leave enough space to add in the middle of each one. Now I spin a 2. So I can go 2 plus 1. Yes.
Do we have to look up all of the combinations, or can we just look up sums?
We're going to need to do all the combinations. Or I'll say I'm interested in the sums. So if you can keep track of all the sums and just write those down, that's fine.
So wouldn't you know that the sums, you could add just the 2 lowest numbers and the 2 highest numbers and know that there's everything in between?
You could, but then there's multiple of everything in between.
Yeah.
So we're going to need those multiples. So if you can get 3 twice, you need to know that we can get 3 twice. In our data set, there's going to need to be 2 3s. Does that make sense?
Yeah.
That's why I'm just listing them out, so then that way I know everything is covered. Uh-huh. So I've written all my possible sums out. I'm going to change ink colors and then go through and write down what they actually add to. And you'll probably real quickly start noticing a pattern. So our data points. Don't do that to me. Don't cover them up.
Good.
gosh, now all my numbers are covered up. Lovely.
Yeah.
Ah, gotcha. An invisible error message. I can't see. Yes, you may. This color already exists. Okay. Ah, fine. Fine, I'll just get rid of the rectangle. You didn't want to cooperate? I'll get rid of it. I was trying to outline the main numbers I'm interested in, but clearly it's not going to let me. Yep, no. Okay, well, it's still ones in blue, just the single digits for what I'm interested in. Okay, so here comes the curveball from what's written on your page. We need to find the mean and standard deviation of these. But we have a calculator to do that. So enter all the sums into a list in your calculator. Like one long list of all 24 sums. Once you enter them in, run your stat calculation. Yes. Okay.
We want to answer the standard deviation.
Let's do 3 decimal places. That's what they give to you up there on the screen. So let's do 3 decimal places. Okay, so what did we get for the mean of x? 6. What did we get for the standard deviation of x?
2.041.
What's that?
2.041.
2.041. Okay. Okay, do we notice anything maybe of interest here? Anything maybe going on with the means or the standard deviations?
Probably 3.
What's
Maybe multiply the standard deviation by 3. And I get the average.
Yeah. What I guess what I'm trying to look for is any relation between what they give us and what we found. What about our means here? If I added my means together, what would I have gotten? 6. So the mean of the sums, this is our mean of the sums. The mean of the sums is the sum of the means.
What was given means for?
These given means, so this given mean is the mean of spinner A, and this is the standard deviation of spinner A. This is the mean of spinner B, and the standard deviation of spinner B. Which it is kind of interesting. It's like, how exactly does that work? The spinner must be rigged. So if we look here, we added these up, we would get our mean. I guess I drew that backwards. (2.5 plus 3.5 gives you 6. Okay, do we notice any relationship by chance with the standard deviations? Does it look like I can just add those? No, that doesn't work. Average them? No, then you can't use average, because then it'd have to be in between them.
Yeah.
What's that?
Yeah.
Yeah. Okay, let's just keep thinking about that one and we'll come back to it. We don't notice anything, so let's just kind of put it in the back of our mind. Look at the next part, see if the next part reveals anything. So let's suppose one variation of the game, to make the game more interesting, the players move the difference of the two spinners. But we're going to do B minus A for our difference. So the B spinner comes first, then the A. Yes. Oh yeah, she's back, so you can go. I didn't say, I'm like, when she gets back, oh, she's back. Okay. So now we're going to do the same process, but for B minus A. So I'm going to need to do 1 minus 3. Oh, wait, why am I starting with a 3? 1 minus 1, 1 minus 2. I need to use more space. 1 minus 3, 1 minus 4, and then go to the next one. 2 minus 1. And the next one. Remember, spinner B goes in front. Then to the next one. Then the next one. And the last one. Okay. I'm gonna change colors and write down all my differences like I did on the last one, kind of in the middle. And then we're going to go through the same process. So put them in your calculator, find the mean, find the standard deviation. Okay, what did I get for the mean?
1.
1. What about the standard deviation?
2.041.
2.041. So what do we notice about these numbers?
The standard deviation is the same as the sum.
Standard deviation is the same as earlier. Repeat that one more time, please.
The mean of B minus A is the mean of B minus B.
That's right. So the mean of the differences is the difference of the means. So it seems that mean is kind of predictable. We know what's going to happen with it. It just follows whatever the data set does. It's a follower. Have we figured out anything for standard deviation yet? What it does? I mean, it stays the same, but it still doesn't help us to see how does this standard deviation compare to the ones they gave us. I mean, like, well, heck, we're still stuck on that one. So I'm going to go back to the PowerPoint unless someone's still trying to write. Are you still trying to get it written down? No? Anyone still trying to get this part written down? Okay, I'm going to go back to the PowerPoint. Okay, we did this. We got that. We got that. So we still have the question, how do we find the standard deviation for sums and differences? That leads us into our next topic. We're about to figure out how we can do it. So I know I left a blank here at the top of page 11. There's not really anything that goes in that blank. Yes, it does. Okay, so let's go into our next topic. Let's see how far we get. Hopefully we should get the first example done, but then we may have to stop. So mean and variances for linear combinations. That's what we were actually just doing. We were taking different means, combining them, different standard deviations, trying to see if we can combine them, and it was not working worth the flip. We couldn't figure out any pattern. So if x1, x2, all the way to xn are random variables, a1, a2 to an are just numerical constants, then we can define the random variable y as a linear combination of the x's. So this is what y is equal to, and that's a blank. That's what goes after that second little paragraph and that big other blank on page 11. So y is constant 1 times x1 plus constant 2 times x2. And we just keep doing that for all x's. Now, in our example that we just did, the a's were either 1 or negative 1. So to get the means, we say, oh, wait, you can just add the means or subtract them, but whatever we need to do to them. Means tend to play nice. So if you have the mean of y, you just do constant 1 times the mean of x1, constant 2 times the mean of x2, all the way till you get to constant n times the mean of xn. That mean could be 1, it could be negative 1, whatever the case may be. Now for the mean, this would probably be something I'll write in my notes. This only works, or take it back, this works every time, no matter if they're independent or not. The mean works every time. Standard deviation, this one down here, maybe you want to write a note on it, only works if they're independent. Standard deviation will only work if they're independent. like I said, standard deviation only works if the x's are independent. If they're dependent, it won't work. Put your hand on the desk. Okay, so let's look at an example. A commuter airline flies between San Luis Obispo and San Francisco. Did someone have a question that was remote? Okay. The commuter airline flies between San Luis Obispo and San Francisco. For small planes, the baggage weight is a concern. As I'm sure you probably know, how much weight in the plane determines whether or not it can take off. So suppose it's known that the variable x equals weight in pounds of baggage checked by a randomly selected passenger, has a mean and standard deviation of 42 and 16 respectively. And we want to consider a flight where there's 10 passengers, all of which are traveling alone. So if they're traveling alone, what could we assume about them? They only have one piece of luggage, but Stephen said the key thing. They're independent. It's not the husband's trying to fit all his wife's extra clothes in his bag and to pack any kids' luggage. Everyone's on their own. They're independent. So the total weight of our checked bags would just be the sum of all the bags. There's 10 bags. So x1 plus x2 all the way to x10. So what's the mean of all the checked bags? What's the mean total weight of the checked bags? Well, let me get my pad here. Let's think of this. We know that for the mean of y, if y is a linear combination, we would do a1 times x plus mu of x1 plus a2 mu of x. Not right. Mu of x2 all the way to, we have 10 pieces of luggage. So a 10 mu of x10. Now, everyone's by themselves, so all the a's, if you notice, there's nothing in front of the x's here. So all these a's are just ones. We don't need them. What's the mean of your first bag? What does it say the mean of each bag is, for that matter? 42. So we're going to have 42 here plus, what's the mean of the second bag? 42 plus all the way till we get to the 10th, 42. The only reason they're the same here is they tell us the mean of each bag is 42. If the mean was different, those would be different numbers. But the mean's the same, it tells us. Okay, so if I add up 42 10 times, we'll end up getting 420 pounds. That's our mean. That's our mean of the total weight, 420 pounds. Then they ask us for the standard deviation on the top of page 12. So since everything's independent here, we can use the formula that we learned. So the standard deviation, first, so they give it to us in terms of variance. So we have to do A1 squared sigma of x1 squared. I'm just writing our formula down that they gave us, then we'll talk about it. So what did we say all the A's were in our case? 1. So really, we don't have to worry about them in this formula. Because A is 1. Okay, so what is the standard deviation for bag 1? 16. So I'm going to do 16 squared because first I've got to get my variance. So 16 squared plus standard deviation of bag 2 is also 16. So we've got to square it. Plus dot all the way to our 10th bag. So if I did 16 squared and added it up 10 times, what would I get? 2,560. Now, this is variance. So our units would be pounds squared. Does that make much sense? Pounds squared? No. It asks for standard deviation. So how do I get standard deviation? Square root it. So the square root of 2,560 is
50.596.
50.596. And we're going to be in pounds. That's all we have time for today. We didn't get to finish. AP, if y'all get to questions that involve this and you're like, I need help, just email me. But there's also examples in the book of this. So I think y'all should still be able to do the whole assignment.
This is what to do with because I was kind of confused with combinations and permutations, but I looked it up and figured it out now. And then I have a question about this. So you multiply actually, right? So all of this you just multiply it. Then how do you simplify it?
I don't know why it says simplify, honestly.
Okay, so you're just gonna rewrite the number? Okay. All right, and then for